Hello everyone. Today I'll be walking you through a production grade scalable three-tier web application architecture on AWS. One that's not only cost effective but follows the well architected framework and hopes to be somewhat educational, especially to those who are still new to the cloud or preparing for their exams or just like a bit more insight on a topic like this. This isn't just theory, it's a kind of design that you'd see in a real project in industry. So hopefully it's somewhat insightful. Um, Before we dive into the main topics in this video, we'll briefly cover over the services that we got going on here and how are they interacting and uh, yeah, we'll start off with that right away. First of all, we've got the users here. They would most likely connect through an external browser or mobile app and immediately be met by Route 53, where they will have a simple domain, essentially a simple domain that hides the complexity behind what's going on. Um, it will then be followed up by Amazon CloudFront, a very powerful CDN for caching and distributing static content found in S3 bucket, which we have here. Um, it's also very good for speed and performance. So CloudFront is a very popular, very good choice in an instance like this. You then have it attached to a AWS Certificate Manager, where uh, it issues and manages your SSL and TLS certificates. It ensures HTTPS encryption across the system for secure front-end access via CloudFront and secure backend calls. So yeah, it's a very good combination of services here. That's all connected to an internet gateway here, and we have our VPCs sitting in this region. We have two different availability zones here as well. So we have high availability, a very good practice. So if one availability zone goes down, we have another one in place. So this upkeeps the uh, time or boost the availability of the system. Uh, so yeah, the internet gateway here, the main purpose of it is to ensure that the services or what's inside here has access to the internet, and that will in particular be Fargate, AWS Fargate here, which if it needs any updates or anything from over the internet, then it can do so thanks to the NAT gateway and the internet gateway here. Um, everything inside the VPC is also it's connected or routed by security groups. Just thought I'd mention that because even though security groups are not in or listed on or displayed in this architecture, it is done through security groups and most likely network ACLs as well. Whether we've got the application load balancer here, this accepts incoming HTTP or HTTPS traffic from users. It distributes the traffic across Fargate tasks running in the private subnet here. It also does health checks and routing rules, and anything you need can be configured here. Um, the NAT gateway here, this allows private subnet resources like Fargate. So in this particular example, because we're making sure that the RDS has no internet access whatsoever, because it does not need uh, traffic coming in from the internet, and that's why it's isolated here in its own separate subnet. But Fargate potentially may need uh, some traffic, such as updates or whatever from the internet. So we've got a NAT gateway here, um, without exposing themselves directly. That's why we're doing it through a through this way. So just to boost the security a little bit. Um, Fargate here is serverless containers backend application, um, running the any server side logic, running ECS tasks orchestrated by Fargate. Um, Fargate abstracts away EC2 instances. You don't need to manage services. Is the beauty behind serverless, which we're going to dive a little bit into a bit later on. And it's securely placed in a private subnet, so it can do its thing. Um, and then you have the Amazon RDS here, which we're running for SQL. So it's going to be a managed relational database. Like I said, in this case, we're using SQL here. You could use PostgreSQL if you need to. So a backend service running on Fargate. It interacts. Fargate interacts with the RDS for read-write data. And once again, it's also protected inside its own private subnet and only accessible by internal services. So in this instance, it will be Fargate. We also have Fargate connected to our secrets manager, because in order for Fargate to run or do any tasks based on the data found in the RDS, it needs the database credentials, which is safely stored in AWS Secrets Manager. Um, and yeah, anytime you need, you can also activate password rotations. So if you want to rotate your passwords every set period of time, you can freely do so here. And it's the secrets manager is not connected to RDS because you don't need to have it connected to RDS. As long as the credentials are in here and Fargate has access to them, then Fargate will be able to free perform its tasks um, without any issues. We also over here have CloudWatch logs, which is sitting outside the VPC. Um, and it's mainly there just to monitor or capture logs that are coming in from the application load balancer, from RDS, from Fargate, from the code pipeline logs as well up here, which we can get into now actually. So if you want to update, if you want to update like your front end or Fargate or anything down here, then the developer can very freely simply just update the code on GitHub, and that will then send a request to fetch the latest code, and it will then be built via code build over here. And yeah, this is a very straightforward, very simple architecture. Nothing well too fancy, but it's still powerful. It still gets the job done. So now we're gonna explore just a little bit of what is going on, like topic to topic. So let's have an architecture overview. So as we discussed before, the architecture has three layers. It's a three-tier architecture. So we've got the web tier, or the presentation layer here in the public subnet. Then we've got the first private subnet here, which is the application layer, where we have our backend stuff. So any API logic or server-side logic will be here. And then we've got the database layer here, or the persistence layer, which is where we've got our RDS for SQL. A tip: in some use cases, the three-tier structure becomes a multi-tier structure. So, for example, if you add other services like feature flags or message queues like SQS, or even event buses like EventBridge, then there's a chance of it evolving into a multi-tier architecture as opposed to your traditional or orthodox three-tier. So, yeah, moving on to the next topic. Let's talk about the VPC and the subnet design. Oh, sorry, didn't mean to zoom out like that. There we go. Okay. So we begin with a custom VPC, and like as I said before, it's split into two availability zones to ensure high availability. The public subnets host the application load balancer and NAT gateways. The private subnets hold ECS containers, so like the backend services and the database here. So everything here is isolated from direct internet access. Each subnet is tagged and scoped, and all communication is tightly controlled via, like I said before, security groups and network ACLs. The philosophy behind this design is to isolate components based on their roles. So this way, it reduces the blast radius. If anything goes wrong, it reduces the blast radius, and it also enforces least privilege access. So yeah, those are the main merits. Another thing to note is when working with multiple teams or even business units, it's often better to isolate environments with multiple VPCs. In that case, you want to explore services like AWS Private Link for secure service access, or even Transit Gateway for centralized routing, or VPC peering even for simple one-off connections. The choice really depends on scale and team structure, and potentially even compliance needs. So you want to make sure you are keeping on top of that. So, all right, let's start with the front end layer. So the front end layer, this is where you'd find like your React or Next.js static site. It's hosted on S3 with CloudFront as the CDN, as you can see. But with this setup, you can serve globally with low latency. It supports HTTPS custom domains. It's incredibly cost efficient because you only pay for what you store and transfer. You may have questions like why not use your traditional EC2s or even things like Amazon Lightsail. It's because, and this is very popular at the minute, it's because having it serverless we want zero maintenance, and on top of that, global edge delivery, and those are the two things that this provides. Um, for lightweight request manipulation, use I would say use cloud functions, things like header rewrites or redirects. Um, I say use Lambda at edge for heavier logic, for example things like authentication at the edge, stuff like that. If you want to process form submissions or trigger logic after uploads, then I would say maybe consider things like S3 event notifications, hook to Lambda or SQS. Um, these are just a few decisions, but make sure you keep in mind the decisions impact the latency and the complexity, and at the end of the day, the cost of the overall architecture. So you want to keep that in mind. Um, Next, moving on, we've got the application layer. So this is once again our backend is in this instance is containerized and runs on ECS Fargate. So you're probably wondering, why are we using Fargate as opposed to traditional EC2s or things like that? So with Fargate, Fargate is extremely popular. If you're preparing for your exams, then do take note, because there has been a spike in questions related to Fargate in the exam. So yeah, Fargate is extremely popular at the minute, and the popularity is only rising. So the reason why we've decided to use Fargate, and the reason why it's extremely popular, is because you do not need to manage EC2 instances. You don't need to manage anything. Serverless means it automatically provisions what you need, so you don't under provision or over provision, and have either no performance or an extremely high cost at the end of the month. So you don't need to manage EC2 instances when you're using Fargate. So this means that it scales automatically with load, which is another merit that comes along with this. And the best of all is you only pay for what you use. So the cost at the end of the month is going to be somewhat predictable. Of course, you already got services that helps you predict what the cost is going to be and forecast and stuff like that. But since you pay for only what you use, this means that you're cutting down on idle time and idle costs. Sorry. So that's a very very good benefit with using Fargate. Um, we can deploy these services across multiple private subnets behind application load balancers, and that's very important, because this, once again, this handles the routing, the health checks, and even SSL termination if you want to, if you needed to. An optional tip, by the way, you can swap the ALB out with an API gateway for serverless REST APIs, but the ALB, the application load balancer, gives you that control. It gives you more control, especially for things like WebSockets or stateful traffic. So that's one thing to keep in mind. So we use Fargate for simple orchestration, or sorry, for simple containerized services, and when you don't want to manage don't want to manage infrastructure. So those are the main two reasons why you'd want to use Fargate, and on top of it being cost effective as well. But if you want that, if you want more fine-grained control over orchestration, CI/CD pipelines, and even if you even want that pod level logic, then you can use EKS or Kubernetes, which gives you that power. But with that power, it comes with more complexity. So you want to keep that in mind. You can choose Lambda if you need pure serverless with like an event-driven architecture and low operation overhead. Um, that is an option you can explore. And once again, with Lambda, you only pay for what you use, so it is cost effective. So that's something you can play around with. Um, Moving on, we've got the database layer here, or the persistence layer. So in this instance, we use RDS for MySQL. It's deployed once again in a multi-AZ mode for automatic failover and durability to secure it. It lives in this private subnet here, and it's only accessible once again through or by ECS via security groups. The secrets are again stored in AWS Secrets Manager, and this is optional based on scale, but for caching, we can integrate Elasticache for Redis to offload those read-heavy queries and reduce latency. So that's something to keep in mind. In high concurrency setups, I'd also recommend RDS proxy to handle DB connection pooling for Fargate. So if you're listening to this and you're wondering what does concurrency mean and what is connection pooling, we can dive into that very briefly. Or now actually, we'll keep it quick. So concurrency simply means just how many things are happening at the same time. In a web app, high concurrency happens when a lot of users or services are like they're sending requests at the same time. So, for example, 10,000 people browsing your site at once, or 500 API requests per second hitting your backend. So that's what we're talking about. And since if these things are happening, each request often comes or often needs to open a connection to the database to read or write data. But databases can only handle a limited number of open connections at once because each one consumes memory and CPU. So if you're using ECS Fargate containers and scale up the number of backend tasks to handle the load, you end up with a lot of containers, and each container might open multiple DB connections. Without control, this can very easily overwhelm your RDS instance, and it can cause things like slower performance, failed database connections, and even app crashes, which is obviously something you want to avoid. So that's why, going back to before, RDS proxy, this helps by acting as the middle layer. It sits in between your app and the RDS database. It manages and pulls database connections a lot more efficiently. Instead of every container making a new connection, they reuse a small pool of already open connections. So this reduces the pressure on RDS. It improves performance, especially when scaling rapidly. So if you're planning on scaling, if you're planning on growing the business or whatever, then you want to definitely keep that in mind. RDS proxy is something that will definitely help. If you're still struggling, or if you're still struggling to understand, then let's use a very simple analogy. So if we're not using RDS proxy, if without RDS proxy, every app container is the equivalent to a person ringing a doorbell separately. But with RDS proxy, if you do use it, it's like when people would line up and to take turns to go through a receptionist. So that's kind of like the analogy we're working with here. It's kind of what's happening. So in short, high concurrency simply means there's a lot of simultaneous users and requests. That means which equals to a lot of database connections, database connection requests. RDS proxy is efficient, scalable, and scalable connection management uh, technique just to avoid database overload. Um, if you need SQL compatibility, but you want better autoscaling and performance, then Aurora Serverless V2 is right there. It is potentially a better option in that instance. But if you want to take a different route, for example, like go for a non-relational or key value access pattern database, then you can go with DynamoDB because it offers built-in global replication and near infinite scaling. So that's extremely good. Again, these are just based on your scaling needs. If you're planning on scaling, then these are options you might want to explore. All of this simply just comes down to access patterns, once again scaling needs, and your consistency requirements. So yes, do keep those in mind when moving forward. Having a strong RDS is definitely important, especially when you're planning on scaling. Um, Next, let's explore the security architecture of this design. So during this development, a motto that we were following was security is a first class citizen. So what have we done to increase security? So first of all, we've got IAM with least privilege roles. Um, we got WAF on A or B for application layer protection. We've got CloudTrail for audit logging. We've got Secrets Manager here for secure credential storage. We've got HTTPS enforced on all layers. The backend has no direct internet access. It reaches out through a NAT gateway, but nothing reaches in. So everything is isolated. Everything has a secure way of communicating with one another, and yeah. Um, the In this example, we we have this design, but let's say for startups, simply IAM plus least privilege is usually sufficient. It's usually okay. But in an enterprise or a multi-account setup, you'd want that service control policies found in AWS organizations. Um, this will help you to centrally enforce guardrails like disallowing public S3 buckets or limiting access to those expensive services. It simply all just comes down to terms of governance and scale, really. So, but it's still important to keep in mind. Um, next topic. Let's move on to observability and monitoring. So, for monitoring troubleshooting, we're using uh, Amazon CloudWatch here, which captures the logs and custom metrics. You can pair this with something like X-Ray, which traces the user requests end to end. That's something you could use. You can also, if you really, let's say you've got a big team and you really want to track resources and resource compliance, you can use something like AWS config. But with CloudWatch, we can just set alarms on key metrics like CPU, memory, and database latency, and you can just auto scale the Fargate tasks as we needed. Um, so yeah, that's what we're working with. But let's say hypothetically, if your app becomes a distributed system, so basic CloudWatch logs aren't enough anymore. We can use something like AWS Distro for OpenTelemetry or ADOT to capture spans from every service. You can send traces to X-Ray or external systems like Datadog or even Honeycomb, for example. And if you've got people on your team that are already fluent with services like this, then it will go well together. Um, so yeah, it's very important. Observability is just telling a story with the data that you have. Next we got our CI/CD. So our CI/CD pipeline. So the code should be ideally versioned on GitHub. So we can use things like AWS code pipeline and code build um, to basically update the infrastructure. So essentially, how this would work is the code changes trigger builds. Unit tests ideally should be run automatically. Docker containers are pushed to the registry, the ECR, um, automatically. Um, it then updates the services and everything is redeployed with ideally zero downtime. It's fully automated, reproducible, and secure. So this is currently what we're working with. Um, to reduce risk further, we can use things like co-deploy um, with ECS to run blue-green deployments, spin up a new version, route a portion of traffic maybe, and monitor before switching over. For Lambda or API Gateway, we should use weighted aliases for canary releases. That's extremely powerful and very good at mitigating potential risks later down the line. Um, these I'll say these patterns are essential in production environments where rollback speed is pretty critical. So yeah, those things you should keep in mind. Um, sorry, let's zoom out of this. There you go. So let's move on to cost optimization. So to keep things lean, we use Fargate and S3. So with these two services alone, there's no idle compute costs. So you're not going to rack up a huge sum at the end of the month simply by having services running and doing nothing. Um, with S3 as well, we can also use things like lifecycle rules. So that way, the data that's stored in there are stored in the correct bucket type. That way, it doesn't you're not paying more than you have to in order to store data. Um, you can turn on saving plans or reserved instances for RDS. That's something you can do. Um, and yeah, I mean you can implement tagging to track costs by team or feature. You can use budgets, AWS budgets plus alerts to notify teams when their spending goes off track. Um, if you're planning on scaling and you want to turn this into a larger organization, it's very important because this visibility can definitely make or break cloud financial management. So you just want to keep that in mind. Um, things are usually best kept lean. It would be best to track things and ensure that there are no cost anomalies at the end of the month. So yeah, just things to keep in mind. So we're going to wrap this up now. So we're going to wrap this up by talking about how this entire structure follows or aligns with the AWS well-architected framework. So there's 6 pillars. For those who are still waiting to do their exams or studying or new to the cloud, there are 6 pillars that any well-architected framework should ideally follow. So the first pillar we're gonna is operational excellence. So we've got services like CI/CD, we've got monitoring, we've got logging. All of these contribute towards operational excellence. Then we've got security. Like I mentioned, like we've got everything is isolated into its own separate subnets. We're using things like IAM with least privilege. We're using WAF on our ALB. We're using security groups for deconnecting or routing things with it internally. We're using secrets manager to store the credentials, database credentials, having it only accessed by Fargate. And yes, things like HTTPS, stuff like that. So we are most certainly aligning with the security pillar. Next is the reliability. So reliability, once again, we're using ALB. It's a multi-AZ setup. So if one availability zone fails, we've still got another one that's running, keeping the app running. We've got ECS scaling. We've got RDS failover. So these things, these features definitely keep the architecture reliable and up and running. Next we have performance efficiency. We've got auto scaling thanks to the application load balancer. We've got CloudFront, once again a very powerful content delivery network that allows global serves globally and got really good performance and speed. We also explored things like Elasticache for Redis with RDS for those frequently accessed queries, ensuring that there's low latency in that. So we're definitely contributing towards the performance efficiency pillar. Moving on, we've got cost optimization, which we did talk about literally in the last topic. With cost optimization, we're using things like serverless compute, so we only pay for what you use. You've got right sizing, so this is making sure you're using the correct size for the feature. So for example, you're not over provisioning and having a more expensive cost at the end of the month, or you're not under provisioning and having a underperforming architecture or product. And also using things like S3 and its lifecycle rules. So yeah, these are the ways that we're cost optimizing. I'm sure there are more other ways we can do this, but this is definitely one of the more cost effective ways I'd say you can design this architecture. And then the final pillar we've got sustainability. So this kind of leans in with cost optimization, but we've got minimal idle infrastructure, so there's nothing that's left running and just forgotten about and racking up costs or wasting resources. So we've got a minimal idle infrastructure, and we've got usage based billings. So once again, you only pay for what you use. So these are ways we're contributing to that sustainability pillar. So we can use the AWS architected tool to audit the workloads. For specific industries like media, finance, or even gaming, we can use custom lenses or industry lenses. These tailor best practices to domain-specific needs. It all comes down to the needs of, I suppose, the client. So yeah, and with that, we will be wrapping this up. I'm going to try and make this a potential series out of this where we explore architectures like this and go over best practices and the pros and cons and the hypotheticals of what you could and could not do. So yeah, so this is a first video. I hope everybody enjoyed and hope to stick around for the next one.